Good morning students. Welcome to the science class. We are doing chapter number 12, sound. Sound is a form of energy. Right? We have studied this in our previous video. We have studied how sound propagates in the form of compressions and rarefactions. We have studied that sound cannot travel without medium. So there will be no sound heard in vacuum. Right? Today we shall discuss about the three important characteristics of sound: amplitude, frequency and time. Now for understanding these three, we shall take an example of the oscillations produced by the pendulum. I have drawn a pendulum here. When the pendulum is steady, when it is not moving, it's at the center. This position is called the mean position. And when we just push it, it will start oscillating to and fro, and it will go to certain distance on both the sides, that we call it as the extreme position. So the maximum displacement from the mean position on either side is called the amplitude of the wave. Sound is also wave, so sound also has wave. We can demonstrate or we can show the sound waves in this form. We can draw the sound waves like this way. So this is the mean position. I am writing M here. This is the extreme position. This is the another extreme position on the other side. So the distance from the mean position to the extreme position, that is called the amplitude. Okay, so let us write down the definition of amplitude: the maximum displacement from the mean position is called amplitude. And the SI unit, because this is displacement, so SI unit will be meter. Now, coming to the second characteristic, frequency. Frequency means number of oscillations in 1 second. Now, suppose this is the same. We draw here this much is 1 second, suppose, and we are drawing 1, 2. See how many? This is one complete wave from here to here. This is one wave from here to here. This is a 1, 2, 3. So here we have 3 waves in 1 second, right? So number of oscillations in 1 second, that is called frequency. Now in some of the waves, here you can see the amplitude is smaller. This amplitude is larger, right? So when the amplitude of a wave is larger, then the sound will be louder. That means we can say amplitude determines the loudness of the sound wave. So amplitude, higher amplitude, louder is the sound. And lower amplitude, softer will be the sound. And frequency determines the pitch of the sound. But first let us write the definition of frequency: the number of oscillations in 1 second is called frequency. SI unit of frequency is hertz. Now, more the frequency, more will be the pitch. Means the sound will be shrill. Like if we compare the voice of an adult male and the voice of a female or a child, the shrillness in the child's voice is more, whereas the male voice is gruff. So the frequency of the child's voice and the female voice is more than that of the frequency in the male's voice. So frequency, more is the pitch. More frequency, higher pitch and shrill sound. So I hope amplitude and frequency are clear to you. Now if I say here there are 3 waves here. If I draw in the same distance, if I draw 1, 2, 3, 4, 5. So here we can say higher frequency. And this is lower frequency. Fine. Then the last one, that is time period. How much time it takes to complete one oscillation? That is the time period. Okay. From moving from the mean position to extreme position and back, how much time it takes to complete one oscillation? That is the time period. So time taken to complete one oscillation is called time period. Okay. Now let us go through 2 of the numericals which are given in your book. One is a membrane oscillates 100 times in a second. So how many oscillations are there? 100 oscillations in 1 second. 100 oscillations and time is 1 second. So how much will be the frequency? According to the definition of frequency, number of oscillations in 1 second is called frequency. Here in 1 second how many oscillations are there? 100. So the frequency will be 100 Hertz. HZ we can calculate. Suppose there are 25 oscillations in 5 seconds. So how much will be the frequency? We have to find out how many oscillations are there in 1 second. So in 25, if there are 25 oscillations in 5 seconds, then we can divide by 5 and find out the number of oscillations in 1 second. So 25 divided by 5 will be 5. So the frequency will be 5 Hertz. Okay. Similarly, it is given that second numerical is a body oscillates 5 times in a second. 5 times in 1 second. What will be the time period? So, in 1 second there are 5 oscillations. According to the definition of time period, time taken to complete one oscillation is called time period. So here 5 oscillations in 1 second. So for one oscillation how much time is required? So it will be time period is equal to 1 upon 5 second. Because it is time, so unit will be second. SI unit of time period is second. So children, I hope with the help of this video you will be able to understand the characteristics of sound, frequency, amplitude, time period and the relation between them. Right? Relation, now F is equal to 1 upon T. Okay? Frequency is equal to 1 upon time period or vice versa. Okay? So this also we can use for our numericals. Okay? So please the concept with the help of the video and go through the topic in the book, and in case of any doubt, feel free to contact me. Thank you.